In this video, I'm going to look at the third case in problems involving trigonometric substitution. Okay, so here are your first cases. Triangle 1, did an example for on that previously. Did another video on number 2 here with the secant. Now the third case, if you have something that looks like this, so you have a square root of a variable squared plus a constant squared. Your substitution then is tangent of u is equal to u over a, or it could be x depending on your variable. So we'll let u or x, whatever the case is, equal to a tangent theta. And then you want to draw your triangle for reference when you get to the end to transform the answer in terms of the original variable. Okay, so let me just go through these. Problem number 1, evaluate each integral. This is the one I did in the first case involving this first triangle here. Okay, so that's your solution for reference. Pause the video, please, if you need to. Number 2, this is the one that I did for case 2. There's your answer. And then here's the third case, which I'm going to do today. And I mentioned to you in the previous videos that when you're working problems like this involving a radical expression, always look for the standard substitution method first, okay? And this is one where you could actually do it. Even the other ones that I did, you might, if you use a u substitution, in some cases you can also use a trigonometric substitution. But generally speaking, the easier way would be to just do the regular substitution. Okay, so this one I'm going to do it both ways. I got x squared plus 9 here under the radical. I got x here, so the derivative of the u substitution. So I'm going to let u equal to x squared plus 9. And therefore du, differential, both sides then, will be 2x dx. Okay, dividing both sides by 2 here, this allows me to replace the x dx over here in the given integral by du over 2. Okay, so I'm going to have here then 1/2. I'm going to put the 1/2 out in front. Integral. Okay, and then x dx will be replaced by du. Then in the denominator, then I'm going to have the square root of u. I'm going to write that as u to the 1/2. And then I can just integrate that. Okay, so this is going to be u, and I guess I have to rewrite it this way. Bring it to the numerator, and make it negative 1/2. Okay, so this is still du here. Okay, so now I'm going to integrate. So the rule then is your basic polynomial term here, so add 1 to the exponent of negative 1/2, and this gives me 1/2. And then you divide by 1/2, and then you got 1/2 as a coefficient here. And then you have your constant of integration. Okay, so the 1/2 here and the 1/2 here cancels. I get u to the 1/2 plus c. But u is x squared plus 9, so I can write this as x squared plus 9 to the 1/2, or write it as a radical, x squared plus 9 plus c, constant of integration. Okay, so this is your solution. So that didn't take very long. Okay. Now this is one though, since I'm trying to illustrate the case 3, this is one where you can also use the trigonometric substitution, case 3. But if you have a choice, this is the way I would do it. Okay. But you might have a problem where the instructor tells you to use the appropriate trigonometric substitution. So we're going to look at that. Okay. So in this case, this is the u, of course, in the problem is x, and the a squared is 9, so a would be 3. So the substitution you make is you let x equal to, you look at this. See, tangent of the angle is u. There's your angle right there, theta. Tangent of theta is, in our case, will be x over a. And you let x equal to a tangent theta. Or of course your a, in our case, is 3. Okay, so we got x equal to 3 tangent theta dx, then differential is equal to 3 secant squared theta d theta, just taking the derivative. And then we're going to basically replace the x over here in the integrand by these substitutions. So where I have an x, I'm going to put 3 tangent theta. Okay, so I'm going to do the bottom part here of the denominator here first. So I got the square root of x squared, but x is 3 tangent theta, so there you go, plug it in, plus 9. And then it's the square root of, okay, so this is 9 tangent squared theta plus 9, okay. And all I did here is I factored out 9 from the radicand, wrote that as 9 times tangent squared theta plus 1, but the square root of 9 is 3, so that comes out here. Tangent squared theta plus 1 stays in there, okay, in the under the radical. But one of your trig identities tells you that this tangent squared theta is the same thing. Tangent squared theta plus 1 is the same thing as secant squared. And the square root of secant squared theta is secant theta. Okay, so that's what this simplifies to. Okay, so then I come back over here and make those substitutions. Okay, so the x is replaced by 3 tangent of theta. Okay, and then over here I did the calculations for the square root of x squared plus 9. That comes out to be 3 secant, and 3 secant theta. Okay, and your dx is replaced by 3 secant squared theta d theta. Okay, so now you simplify. I got secant squared theta and secant over here, so we can cancel one here, one factor here. This 3 and this 3 will cancel. So we wind up then with the integral of 3, and we got tangent theta secant theta, and that's d theta. Okay, next step then is to integrate with respect to theta here. But tangent theta secant theta, that product, antiderivative of that, the constant, remember, we can bring out here. So the antiderivative of tangent theta secant theta, or secant theta tangent theta, whichever way you want to arrange that, is going to be secant theta. And then this is 3 plus constant of integration. Okay, so that's the answer in terms of theta, but we want to give the answer in terms of the original variable, which is x. Okay, so all we have to do from the reference triangle, we need to find secant of theta. Okay, so again, let me write the triangle right here. So you got your theta here. And we know that tangent of theta is x over 3, so we have to put the x on this side over here, opposite the angle, and 3 is adjacent. So the hypotenuse then would have to be square root of x squared plus 9. Okay, so then from there, to finish the problem, we simply look at the triangle and say, okay, what is the secant of theta? Secant of theta is hypotenuse over the adjacent side, so that's the square root of x squared plus 9 over 3, and that's times 3 here, plus your constant of integration, but these 3's here will divide out, so we get an answer then of the square root of x squared plus 9 plus your constant of integration. Okay, so this is the same answer we got using the standard U substitution. So again, if you have a choice when you're working these problems, whether it's on a test or a homework, the first thing you want to look is your standard U substitution, because that's going to be a little bit easier in terms of the steps involved. In this particular case, you saw what the steps were. This one wasn't really too bad using the substitution method, but the answer was obtained quicker using the standard U substitution. Okay, so that's your solution. Thanks for watching. We'll see you in the next video.